Day 3. I wasn't here for day 2. I mean day 1.
Which at the time was, again, relatively small size project. Vendors out there, whether they're cloud service providers or people who build tools for private clouds, that make it so much easier today to move workloads across different cloud environments. I think this is one of the single most successful programs I have ever witnessed, getting us closer and closer to a truly open, truly portable cloud computing world. It is an amazing feat in a short period of time. So I just want to give you some flavors of how this is really working, how a great project can beget incredible products that create value in all of our lives, and how that reinvestment loop happens. But you know, sometimes this doesn't always work. Generally what we see is the most successful open source projects almost all similarly enter into that positive feedback loop, right? But there are projects, open source projects out there that are critical to the security or integrity or stability of the internet that are incredibly widely deployed that somehow fall out of that cycle. And I wish I could come up with a good pattern for why that is. The best I can say is it's very Tolstoy-esque, right? Where all good projects are generally in that positive feedback loop in a similar way. All happy projects are similar. And all unhappy projects are miserable in their own and very unique way. And a good example of this is the OpenSSL project at Heartbleed. And I'm just kind of picking on Heartbleed because I think it's a very well-known example, but there have been more recent examples of problems in open source projects that have created security problems for all of society. But how many people here have heard of Heartbleed? Most people. For those of you who haven't, OpenSSL is an open source project that's the little lockbox on your web browser that encrypts traffic on the web. And Heartbleed was this critical bug in the OpenSSL open source project that essentially exposed everybody's private data to everybody else. One of the, at the time, most gnarly, difficult security vulnerabilities anybody had ever seen. And when we started looking at OpenSSL, we discovered something somewhat disturbing. The OpenSSL project was a small group of people that had been surviving on less than a couple $1,000s a year in sort of charitable donations to some degree. And the two folks that we found that were really committed in working on this project were a guy named Steve Henson, who's a developer in the UK, a guy named Steve Marquez, who was living in Maryland, I believe, at the time. And they were really the ones doing a lot of the work on this project. In other words, when Heartbleed happened in 2014, the internet was essentially secured by two guys named Steve. It's kind of disturbing when you think about it. And this sort of illustrates the importance of all of us to not just look at how we can create sustainable projects like an automotive platform or a Kubernetes or a Linux, but also remember these little projects that may be important to the internet or to the security and integrity of all of our lives and give them a little love. And you know what? It turns out a little love goes a long way. That these unthanked developers who were doing incredible work on a very complex code base needed a little bit of help, and they were able to lift their community up and really go and refactor the code. We performed a commercial audit of the entire OpenSSL code base. With a little bit of funding, we were able to do all of that. They were able to increase the number of participants in the project. They were able to greatly reduce the backlog of bug fixes and problems that they had in that code base. You can just see the spike in activity when these folks got a little bit of attention. And at the Linux Foundation, we started this thing called the Core Infrastructure Initiative to go help projects like OpenSSL that are critical to all of our lives and have some problems or are unappreciated and underfunding. And we gave some money to these folks, and other folks also gave them money and resources to go help this, and it helped. And there are other projects like this. Network time, NTPD, the way time gets synchronized over the internet not too long ago, was essentially maintained by one person down in San Jose that had a little GPS antenna on the side of his house. And, you know, the timekeeper of the internet was just one person who was maintaining this 30-year-old code base. And this is the thing I want to say is, you know, we've got to not only produce sustainable projects, we've got to fix and help out those unappreciated projects. And I think then, if we do both those things right, we really are going to be all better off. And at the foundation, you know, we keep thinking about what else can we do to support sustainable open source. How can we make this flywheel of projects and profit and value creation fly even faster? And so we've been thinking about different ways that we can help everyone do that, and we created a bunch of projects that any of you can participate in if you want to help improve that as well. The first question we ask is, how do we answer this question we get all the time, which open source projects matter, or which ones are healthy, or which one is going down the wrong path and we need to go help this one out? And what we thought is, we should create an open source project to go figure that out. So what we created was something called CHAOS, and this is Community Health Analytics for open source. The idea here is that we need to have a common set of very simple metrics to be able to help us all collectively understand if a project that we're investing our time or our company's money or engineering resources on is one that I can trust, one that's governed in a fair way, one that has a healthy, diverse community of developers who treat each other well, and is being used in important ways. Something that's licensed under an intellectual property and copyright regime that's stable, well understood, and is compatible with lots of other code bases. And so we went and did that. This is a project at the Linux Foundation. Just go to our website and find it, that anyone can participate in to help develop these metrics over time. What we hope to answer with this project are a few simple questions. What's the most important open source software in the world? Who's writing it? Why are they writing it? And is it worth it? Is it sustainable? Something we should invest in. The next thing we started thinking about is, how do we help organizations get the most out of open source? And I want to be clear, I'm talking about organizations, because if you're all developers, I think you already get it. You understand the value of co-developing with really smart people and solving difficult problems. The problem usually ends up, at least in my experience, and I've been doing this for quite a bit of time, is it's the lawyers or the business decision makers who often get in the way of allowing developers inside of a company to collaborate with developers outside of their company. But you know, if 80–90% of the code that anybody uses to create any technology or product or service is coming from outside of a single organization, the question that any responsible company should be asking is, how do I manage external R&D? And so we created a set of guides at the Linux Foundation to help organizations do just that. How to create an open source strategy, how to use tools to manage which open source they bring into their organization, how to modify that code in their product development process, and then how to share back those modifications with the collective once they have made them in that product cycle. Right? How do you measure the success of that? Which licenses do you pick to bring in? How do you share what you want to share and keep what you want to keep? And hundreds of organizations have started adopting these practices. And what we're really seeing is even more companies coming in and starting to feed into this feedback loop of contributing upstream, productizing downstream, modifying and improving, and reinvesting. And this is the guide that tells you exactly how to do it. Finally, the last, and I think this is one of the most important topics that we think a lot about these days, is if we're all dependent on open source code, how do we create more secure code? And we don't have to go too far back in the news in the last couple weeks here to understand just how important cybersecurity is to all of our daily lives. And if you think about it, if we're all collectively dependent on this open source code, and let me assure you, if folks think like, oh, well, if everybody has everybody else's source code, like we're less secure, I mean, we can have that debate. I would argue you're more secure if you can all view source code together, because you can all collectively remediate security vulnerabilities. But even that argument doesn't hold water, because you know what? It's too late. It's already out there. Like, it already runs everything. And so we're already in this collective codependency boat. And the thing we need to figure out is how to create better code and how to create less vulnerability so we have a higher bar of cybersecurity in the world. Think of it this way. Back in, I think it was maybe 2003 as well, Microsoft was having serious security problems with Windows NT at the time. Does anybody here remember when, it seemed like every other day, Windows NT server was having some kind of cybersecurity? There were tons of Microsoft problems. I see one hand from a guy I know was working at Microsoft, I believe at the time, or is from Seattle. This was a huge problem for the company. Bill Gates wrote one of these famous letters that basically said along the lines of this: stop all production. Stop everything. We have got to figure this cybersecurity problem out. We are going to require all of our developers to take secure coding practice courses. We're going to do a better job testing our code. We're going to do better threat modeling of our code. We are essentially going to create a set of processes, practices, and development that'll help us create more secure code. And you know what? It really worked. Like, Microsoft's security story got massively better. You know, Steve Lipner, who is someone who I know, who ran a lot of that program, I think is just an amazing person in terms of transforming that organization's thoughts around how to create secure code. So that worked for Microsoft, but here's the rub in open source. In the case of Microsoft, one person could say, stop coding or you're fired. If you don't learn this, you're out. How do we do that in open source? Who's going to fire whom? Right? This is all a collective, somewhat voluntary, participatory model, right? Even though some people are getting paid professionally to work on this, there's no firing of, you know, an Intel executive can't fire a Google executive or a developer that's working on something. Here's what we ought to do. We need to create a culture of secure coding. It's ultimately a cultural issue that can help create more secure code. You know, the culture of free software and the idea of share and share alike is an ethos that I think has been a critically important part of the open source movement. It's an intrinsic motivation that the concept of sharing itself is a huge personal motivator, far beyond money. What if we could create a similar culture of responsibility around secure coding practices? If we all took secure coding seriously enough, both at the maintainer level, the people who make decisions about what code gets pulled into a project, at the contributor level, like the people who actually can submit that code, you know, and even just at the level of bug fixes and people who are coming in and out of projects. What if we could create that culture? Here's what would happen. It would be harder to get into a system. It would be harder to have these cybersecurity attacks because most of these attacks come from simply bugs in software. It doesn't matter if it's proprietary or open source, but at least in open source, we can collectively look at ourselves and say, how do we make the world better for all of us? And so at the Linux Foundation, one of the things that we're working on through our core infrastructure initiative is a project to start creating that culture. So we created this best practices badging program. And that program basically gives developers a way to go and show that they take secure coding seriously, that they have responsible disclosure practices, that they have a security mailing list. It's a set of things that an open source project has to do to show we really care about this. And then they get a badge. It's kind of like a merit badge or a seal of approval that says, hey, we take this stuff seriously. And what we're hoping is projects like Linux, I know Kubernetes has gotten this badge, will come together And we will really create a world where this is part of the conversation of any project. When you start a project, testing is part and parcel to how you submit a patch. Taking secure coding seriously is just a part of what we all do. We think that's really going to improve the security of all of our lives.